Hello, today I'm going to have a look at the shuttle sort algorithm used for sorting numbers. The idea of the shuttle sort is it's like you're in a shuttle, you're going out to a certain point, dropping off supplies, going back. Then because you've got supplies, you can go a bit further, go back. You can then go all the way to the end and back. So that's what we're going to be doing when we're doing the shuttle sort. Here I've got a random card generator and I'm just going to randomly generate some cards. So it should be entirely random what order these come out in, and hopefully they'll be in a reasonable order for us to sort them. So we've got a 10, we've got a 7, we've got a 9, we've got a 10, we've got a 2, and we've got a 1. So like we did originally, we're going to start off close to where we start, and I'm going to sort these into increasing size. So I want the smallest number first and the biggest one at the end. So I'm going to start with my first two. I'm going to start with my ace and my 2. Well, let's write out the order the cards started in first. I'll start with my ace and my 2. Do I need to swap them? No, they're already the right way round. That's my pass. So I've done one pass and my numbers have stayed exactly the same. In that pass we did one comparison and we did no swaps. Now my ship can go out a little bit further and I'm going to compare my cards. Well, I've got my 2 and my 10. I don't need to swap them. Then normally what we would do is we'd move on and we'd have a look at our first cards. But in the shuttle sort algorithm, as soon as you don't swap a card, that's the end of the pass. So I can write this down as 1, 2, 10, 9, 7, 10. So again, I did one comparison and I did no swaps. And now my shuttle can go a little bit further out. And now I am going to swap my 10 and my 9. So I'm going to compare my 10 and my 9, and I'm going to swap my 10 and my 9. I'll compare my 2 and my 9, and I don't need to swap them. And as I said before, with shuttle sort, as soon as you don't need to swap, that's the end of the pass. So we're going to have 2 comparisons, but only 1 swap. And we're going to have 1, 2, 9, 10, 7, 10 at the end of the pass. Okay, now I can move my shuttle a little bit further out. I'm going to compare my 7 and my 10. Well, 7's less than 10, so I am going to swap them. That's 1 comparison, 1 swap. Now I'm going to compare my 9 and my 7. I'm going to swap them. That's 2 comparisons and 2 swaps. Now I'm going to compare my 2 and my 7, and I'm not going to swap them. So I'm going to get, at the end of my pass, 1, 2, 7, 9, 10, 10. So that was 3 comparisons and 2 swaps. And then for my final pass, my shuttle moves all the way to the end. I have a look at my 2 cards. They're the same cards, so I don't need to swap them. So I'm just going to write down my final pass, and that was 1 comparison and no swaps. If you forget to write down the number of comparisons and swaps, then the number of comparisons will always be 1 more than the number of swaps unless the number of swaps is the same as the number of times you can move. So if we have a look, let's work out the number of swaps first. That's the easiest one to do. If you have a look, all my numbers have just gone straight down. So I know that there was no swaps. And then the number of comparisons, because n was 1, or it was past 1, I didn't do all the possible swaps, so the comparisons will be 1 more than the number of swaps. Let's have a look at the next row. Well, because all my numbers have gone straight down, I know that there were no swaps. And because n this time was 2, and the number of swaps isn't the same as the maximum, I know that the comparisons must be 1 more than that. If I have a look at my next one, because one of my numbers hasn't gone straight down, I know that there must be 1 swap, and the number of comparisons is going to be 1 more than the number of swaps, because again, I've not got up to my pass number. If I had done 3 swaps, then the number of comparisons would be 3. Let's have a look at my next row. So I go down, down, Right, so you can see now I'm going 2 numbers to the right, so that means I must have had 2 swaps and the number of comparisons, because n is equal to 4. Well, the number of swaps isn't 4, so it must be 1 more than the number of swaps for my comparison, so that's going to be 3. On my last one, you can see we've just gone down, 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 so that there's no swaps, and therefore there must be 1 comparison. Okay, I'm going to have another go, do another example with you. This time I've made sure that the numbers have come out a bit more jumbled, so hopefully you'll get to see how shuttle sort will normally come up in an exam context. So the first thing I'm going to do is I'm going to start at the very left hand side. I'm going to compare 9 and 10. Well, I've compared them, they're in the right order, so I don't need to swap them. So I'm going to write at the end of my first pass all the numbers, and because I've not changed any, I'm going to write them as they are. Then I'm going to move on to my second pass, and I'm going to have a look at my 10 and my 2. Now what Shuttle Sort does is it gives you a sorted list to the left of where you're looking, and then it takes the card you've got and moves it to the right place in that sorted list. So we're expecting this 2 to end up at the start of our list. Let's see if that's what happens. I look at my 2 and my 10, I compare them, the 2 smaller, so I'm going to swap them. Then I have a look at my 2 and my 9, I compare them, the 2 smaller, so I'm going to swap them. So that was 2 comparisons and 2 swaps. Now because the 2's got to the end, that's the end of my pass, so I'm going to write out my numbers, 2, 9, 10, 10, 7 and 1. Right, for pass number 3, I compare my 10 and my 10. Because they're the same card, I don't need to swap them, and we know that when I don't swap cards in Shuttle Sort, that's the end of the pass. So I'm going to write out the cards as they are. And then I'm going to move on to my next pass. So now I'm going to compare my 7 and my 10. I do need to swap them. I'm going to compare my 7 and my 10. I do need to swap them. I'm going to compare my 7 and my 9, and I do need to swap them. I'm going to compare my 7 and my 2, and I don't need to swap them. So let's write out that pass. So we get 2, 7, 9, 10, 10, 1. Right, let's have a look. Say I can't remember the number of comparisons and swaps. Let's have a look at and see if we can work it out. Well, the 2's not changed, the 9 has moved, the 10's moved, the 10's moved. So that means that there's going to have been 3 swaps. Well, because this is on pass number 1, 2, 3, 4, the 3 swaps isn't the same as the pass number. You can see here where we had our pass number being 2. The number of swaps was the same as the pass number, and therefore the comparisons was the same. Here it's not, it's 1 off, so we can add 1 and we can say that the number of comparisons must have been 4. And if we count it, we can see that it was indeed 4. We had 1 comparison, 2 comparisons, 3 comparisons, 4 comparisons. And then for the final pass, I compare my ace and my 10 and I swap them. I compare my ace and my 10 and I swap them. I compare my 9 and my ace and I swap them. I compare my 7 and my ace and I swap them. I compare my ace and my 2 and I swap them. So let's write this out. We have 1, 2, 7, 9, 10, 10. And again, let's work out the number of swaps from looking at the numbers. Well, my 2's moved once, my 7's moved, my 9's moved, my 10's moved, my 10's moved. So that's 1, 2, 3, 4, 5 swaps. As you can see, this is pass number 1, 2, 3, 4, 5. So because the number of swaps is the same as the number of passes, I can't add 1. So I'm going to say that the number of comparisons must be the same as the number of swaps, must be 5. Right, let's have a look at the best case and the worst case scenarios. So in the best case scenario, all my cards are sorted. How many comparisons and swaps am I going to need? Well, let's have a look. I'm going to use C for comparisons and S for swaps. Well, on my first pass, I have one comparison, and I don't have to swap them, so that's the end of the pass. On my second pass, I have one comparison, and I don't swap them, so that's the end of that pass. On my third pass, I have one comparison and no swaps, so that's the end of that pass. On my fourth pass, I'm going to have one comparison, no swaps. On my fifth pass, I'm going to have one comparison and no swaps. So the best possible situation is there's going to be the same number of comparisons as passes, and I know that I'm going to do one less pass than the number of cards. So the best case scenario is if there's n numbers to compare, I'm going to do n minus 1 comparisons, and I'm going to do no swaps. Now the worst case is when the cards are in the opposite order to how I want them. So let's have a look again. All right, this time I'm going to keep a note of the pass number as well. So on pass number 1, I compare my cards and I do need to swap them. So that was one comparison and one swap. On my second pass, well, this means we can move over to here now. I compare my 6 and my 8, I'm going to swap them. Then I compare my 7 and my 6, and I swap them. So that was 2 comparisons and 2 swaps. On my third pass, well, I'm going to compare my 4 and my 8, and I'm going to swap them. I'm going to compare my 7 and my 4, and I'm going to swap them. I'm going to compare my 6 and my 4, I'm going to swap them. So that was 3 comparisons and 3 swaps. You can probably start to see the pattern now. Let's just finish it off. Pass 4, I compare my 3 and my 8, and I swap my 3 and my 8. Then I compare my 3 and my 7, and I swap my 3 and my 7. I compare my 6 and my 3, and I swap my 6 and my 3. I compare my 3 and my 4, and I swap my 3 and my 4. So that was 4 comparisons and 4 swaps. And then the last one, I compare my 8 and my 1 and I swap them. I compare my 7 and my 1 and I swap them. I compare my 6 and my 1 and I swap them. I compare my 4 and my 1 and I swap them. I compare my 3 and my 1 and I swap them. So in pass 5, I do 5 comparisons and 5 swaps. So what's the worst case scenario? Well, what's going to happen is that the first pass I'm going to have 1 swap and 1 comparison. The second pass I'm going to have 2, then 3, then 4, and that's going to keep on going all the way up to the total number of passes, and the total number of passes is going to be 1 less than the number of cards. So that's going to be n minus 1. So what we're doing is we're adding up our natural numbers all the way up to n minus 1, or depending on how far you are through FP1, you might know the formula for this already, but we can work this out from our core 2 knowledge. The first term, well, the first term is going to be 1. We need to know the common difference, well, the common difference is going to be 1, and we need to know what the number of terms is. Now, I'm going to say ns for the number of terms in the sequence. I'm going to say that that is n minus 1. So this is a different n to this n. So we're going to say that the sum of the first ns terms is equal to a half n 2a plus n minus 1 times d. Now I can substitute in my values. I get a half. Well, this here is ns, and this is also ns. So I'm going to replace ns with n minus 1. Now I get 2 times 1 plus ns again I'm going to replace by n minus 1, and I'm going to replace d with 1. When I simplify this, I'm going to get a half n minus 1, and inside my brackets I'm going to get 2 plus n minus 2 times 1. So you should be able to see quite quickly that this becomes a half n minus 1 times n. It's quite similar to the formula for the triangular numbers. The formula for the triangular numbers is equal to a half n plus 1. but it's because we're not going up to n, we're going up to n minus 1. So if you've remembered this formula, you could change the n's here for n minus 1s, and then you'll get this formula here. So this is the worst case scenario. In the worst case, it's going to be a half n minus 1 times n. And what we like to do in decision maths is there's a bit too much detail here. When we get into the big numbers, all we really want to know about is what the highest power is. If I expand this, we're going to get a half n squared minus a half n. And you can see that the highest power is n squared, so we're going to say this has quadratic order. In terms of how bad it gets when n gets large, it's the quadratic part that's going to dominate it. Okay, so let's have a look at how this works in an exam question. Tom has some packages that he needs to sort into order of decreasing weight. The weights in kilograms given on the packages are as follows. So before we start, we've got 3, 6, 2, 6, 5, 7, 1, 4, and 9. We're asked to use shuttle sort to put the weights in decreasing order. So we're going from the largest to the smallest. We've been looking at putting things from smallest to largest. We want largest to smallest. So that means when I swap them, I'm going to swap them to make the biggest thing on the left-hand side. Show the results at the end of each pass. Right, it's quite important that you read the sentences really carefully. So we're showing the results at the end of each pass, not whenever we swap them. And write down the number of comparisons and the number of swaps used in each pass. So I think the clearest way of setting this out for the examiner is to say, look, I'm doing pass 1, and then add in at the end a column for the number of comparisons and the number of swaps in that pass. So I'm going to compare my 3 and my 6. And because I want the biggest number at the start, I am going to swap them. So I'm going to say 6 and 3, 2, 6, 5, 7, 1, 4, 9. That's the end of the pass. So I'm going to say that there was 1 comparison and 1 swap. In my second pass, I'm going to start off having a look at my 3 and my 2. They're already in the right order, so I don't have to swap them. And because I've not swapped them, that's the end of the pass. So that was 1 comparison and no swaps. In pass 3, well, now I'm going to have a look at my 2 and my 6. Now, if you remember, we said how shuttle sort works is we have an ordered list, 6, 3, 2, that's ordered in decreasing size. Now, shuttle sort moves the next number into the right location in that sorted list. So I can do it. I can say, look at my 2 and my 6, I'm going to swap them. Look at my 3 and my 6, I'm going to swap them. Look at my 6 and my 6, I'm not going to swap them. Or if you remember that we're going to end up with moving our 6 into the right place in the sorted list, we can write down that it's a 6, 6, 3, 2. And then we can use our trick of looking at where the numbers have moved. Well, the 6 hasn't moved, but the 3 has moved and the 2 has moved, to spot that there's going to be 2 swaps. And because it's pass number 3, I can add 1 to the number of swaps. So I'm going to say that there were 3 swaps. On pass number 4, so now we're going to compare our 2 and our 5. And again, we're going to move the 5 to the right place in the sorted list. So I know that that's going to be 6, 6, 5, 3, 2. And then everything else just stays the same. And then how many swaps was that? Well, our 6 stayed the same, our 6 stayed the same, the 3's moved, the 2's moved, everything else is the same. So that was 2 swaps and 3 comparisons. In pass 5, so now we're having a look at our 2 and our 7. We know that the 7's going to move into the right place in our sorted list over here, and then I just write in the rest of my numbers. So if we have a look at this, my 6 has moved, my 6 has moved, my 5's moved, my 3's moved, my 2's moved, everything else is the same. So that was 1, 2, 3, 4, 5 swaps. And because it was on pass number 5, I can't add 1 to the number of swaps. 5 is the maximum it could be, so I must have made 5 comparisons as well. If you're not convinced about this, I do recommend you do it slowly and check them. But indecision, time is one of the things which you're up against, so you do need to be making sure that you're making the best use of your time. Past 6, I compare my 1 and my 2. You should be able to see I have a nice diagonal of my underlined numbers. But 1's already in the right place in the sorted list, so I can just write it all out. I didn't have to swap them, so that was 1 comparison and no swaps. In past 7, well, now I'm comparing my 4 and my 1. We get 7, 6, 6, 5, 4, 3, 2, 1. And that was my 7's not moved, my 6 hasn't moved, my 6 hasn't moved, my 5 hasn't moved, my 3 did move, my 2 did move, and my 1 moved. So that was 3 swaps and 4 comparisons. And then finally, I compare my 1 and my 9, and this is past 8. I'm going to move my 9 to the right place in my sorted list. And then if we have a look at the number of swaps, that's 1, 2, 3, 4, 5, 6, 7, 8 swaps. It was on pass 8, so the number of swaps is the same as the pass number, so the number of comparisons must stay the same. Right, if we have a look at the question, make sure that we've done it. The question asks us at the end, write down the total number of passes, the total number of comparisons, and the total number of swaps. So to finish off, we're going to say passes, well, I had 8 passes, comparisons, well, this is just a case for adding up our numbers. 1 plus 1 is 2, plus 3 is 5, 8, 8 plus 5 is 13, 14, 18, 26. And then for the swaps, again, I'm just going to add up all the numbers in the swaps column. So I'm going to add up 1 plus 2 plus 2 plus 5 plus 3 plus 8. And I'll get 21. And that's my 6 marks. So as you can see, it's a little bit laborious, lots of room for careless mistakes. Be really careful as you're following through an algorithm, but Shuttle Sort you should be looking at and going, nice easy marks. 6 marks is a fantastic number of marks for an exam question. Well, I hope that explains Shuttle Sort to you, and good luck when you go away and practice it.